There we go. All right, this section is on ternary ionic compounds. If you recall, last section was binary ionic compounds. What did binary mean? Two. Yeah, so there's two elements in binary compounds. What do you think ternary is going to be? Three. It's like the third level or something like that is what it really means. For us, we're going to say they're compounds that generally contain three or more elements. Ternary contain three or more. What it's practically going to mean is they will have a polyatomic ion. All right, that's the stuff on our pink sheet that we got last unit, and we will be using a lot this unit. All right, the polyatomic ions. I'm going to scroll a little bit. All right. How we know that they have a polyatomic ion or that they are ternary is the polyatomic ions are generally going to be negative, and they're going to end with ATE or ITE. If you have the ending of ATE or ITE, you know, oops, I'm going to have my pink sheet. All right. Are there exceptions to that? Yes, and I'm going to point that out here in a second. Okay. The first exception will be our only positive polyatomic ion we're going to deal with, and that is ammonium. Ammonium is NH4. It's on our pink sheet, and it's got a +1 charge. All right? So I will guarantee on the test even, I will have at least one person every hour tell me, I can't find ammonium on the periodic table. And I will just tell them it's because it's not on the periodic table. And hopefully then they will get it. They will figure it out from that clue. All right? But ammonium is on our pink sheet. All right? I've actually had one person every hour, because there's one of those on our assignment today, ask me, hey, I can't find ammonium on my periodic table. And I kind of laugh because it's on the pink sheet. All right? Okay, I'll give you a second to write these down. And then after you get in writing this down, grab your pink sheet, get it handy. We're going to mark a couple things so that we will, they're going to be the exceptions. I think marking it helps you to remember it, and at least it's kind of bold. All right. And guys, after this hour, these will be posted online, so you will be able to get them off of there if you missed something or you think you messed something up. All right, I'm seeing, I think all pencils are down. Okay, so first of all, on your pink sheet, a couple things. This is something I typed up, so the organization is everything in the first column is a -1 ion. Second column is -2. The third column is kind of broken down. This section is -3. Our only -4, and our only +1. If you want to circle or star or highlight your ammonium, that way it kind of pops out to you, I would do that. The next exceptions I'm going to point out to you are our exceptions for the ending, okay? Azide is our first exception. It is a polyatomic ion, but it ends in IDE, all right? And it's an exception also because it is just one element, but it's N3 with a -1 charge, okay? So that whole thing acts as a unit. So it makes it a little trickier when we're trying to find it, all right? The next thing going down, about 5 down from there, is cyanide, okay? Maybe you've heard of that before. It's a poison, all right? Or in many forms, it's poisonous. All right, it is, again, ending in IDE. And it is carbon and nitrogen with a -1. So put a little star by those. It'll help them pop out if you're sitting there going, I can't find cyanide on the periodic table. It's because it's on here, okay? The next one, and this one is, again, one you might want to star and highlight because we use it a lot. It's hydroxide. It ends in IDE. Hydroxide is OH with a -1. OH with a -1, all right? And hydroxide, if you guys have heard of acids and bases, right? In biology, I think they talk about that some. I don't think we're going to get to that unit by the end of the year, but you will know those. bases all contain hydroxide, okay? Common bases, all right? So hydroxide is what's in a base, and as Megan Trainor taught us, it's all about the base. Come on, that was a good one. No, oh, that's going to be on YouTube too. Oh, bad me. All right, anyway. All right, hydroxide. And then the very last exception we're going to have is peroxide. Peroxide is, again, a polyatomic ion, but it ends in IDE. And it's another single element polyatomic ion. It's O2 with a -2 charge. It is not very stable. It's not very stable. That's why we use it to clean cuts and stuff, because that oxygen will then separate out when it can, and it attacks the bacteria. It also attacks our skin. So you use it to clean it out, but I was told by a doctor friend of mine, you do not want to apply it over and over like every day. It will keep it from healing. So put it on there, clean everything out, kill all the bacteria, and then use like an antibiotic ointment or something like that from then on, all right? So just something I learned, and I'll pass it on. Now, there is one typo because again, I typed all this up. On the thiosulfate, it's in the -2 column. It should be -2. I got -3 there. Change that to -2 if you would, so you don't make that mistake going forward, all right? Bad me, okay? So thiosulfate should be -2. All right. Oh, the one more thing, guys. They are, each column in there, or each grouping is in alphabetical order. So when you're trying to find them, you're like, where would nitrate be? Well, it'll be where the N's are. Or where's sulfate? Oh, there's no S's in the first column. There it is. There's sulfate. You see what I'm saying? You'll find it quicker because everything's in alphabetical order. All right, all right, all right. Okay. Let us go to examples then. Hold this phone. All right. So for our examples, and we do these just like we did the regular ones. All right. The first one is going to be potassium sulfate. Potassium sulfate. So let's start out. Potassium. What's the symbol for potassium? K. All right. And what's its charge? +1, because it's in the first column on the periodic table. Then sulfate, I know it's a polyatomic ion because of the ATE, and I just mentioned it, I think, earlier in my notes. All right, we look, not in the first column, come down here. Now, be very careful. Sulfate and sulfite are in a family. They're kind of related, but sulfate is SO4 with a -2. Sulfite is SO3. So we want the sulfate, SO4. So we write that down. And this will be capital S, capital O, little 4. And the whole thing is -2. All right? Now we do it just like we did before. We got +1 and -2. What's the whole thing need to come out to be? 0. All right? And so which one do I need more of? Yeah, I got to have another potassium, right? You can do it that way. So now I have +1 and +1. That's plus what? 2 and -2. So they're going to balance. How many K's do I have? 2. So I can just go K2 SO4. As long as I only need one of these guys, then I just write it just like that. K2 SO4. But the math is exactly the same. You could still do least common multiple. Least common multiple is 2, right? 2 divided by 1 would be 2. 2 divided by 2 would be 1. We just have 1 SO4. Are you with me? Is that super difficult? All right, do a little scrolling. All right, so you might say, okay, that's great if I only need one of the polyatomic ion. What if I need more than one polyatomic ion? You might say that, right? You might say that. Somebody might say that. Somebody might say, what if I need more than one? I'm glad you asked. If you need multiple polyatomic ions, you must place them in parentheses. What? What do you mean? All right, let's look at one, shall we? Magnesium nitrate. What's magnesium? What's its symbol? Mg. Oh, let me switch pins. Let's go red. All right, Mg. And what's the charge for magnesium? 2, plus 2, yep. All right, and then nitrate, go into our pink sheet. It's an N, so we go down to the ends. There it is. Again, nitrate, nitrite, be very careful. Nitrate is NO3 with a -1. Okay, what's the least common multiple of 2 and 1? 2. We'll do it this way on this one. What's 2 divided by 2? 1. So just 1 mg. What's 2 divided by 1? 2. So when we do this, if we go NO3, 2, what's that look like? It looks like 32 oxygen. It is not 32 oxygen. So we put parentheses around the NO3, and then we have the 2 on the outside, and that indicates I have 2 of these guys, which would be 2 nitrogens and then 6 oxygens, doing the whole math, algebra, distributive property. Right. You guys remember that? Oh, yeah. Distributive property. Do a little cross-curricular stuff. Okay? Now, we have to use parentheses even if there's no number here. Yes, sir?
Do we ever simplify this?
No, not in this case. Oh, you mean like distribute it out? Okay, because he meant like distribute out. We would not write it as N2O6 for this part because that's something totally different. The nitrate ion is a particular ion, and it stays together. This is the one that in foods and stuff, it's used as a preservative in some deli meats, and they were saying too much of that can possibly, I haven't seen definitive studies, but might have some effects on developing fetuses. So they have cautioned expectant mothers not to eat too much deli meat. Some avoid it altogether. You're probably okay with that too, but it's one of those things. Phosphate is another one. It will actually rob your body of calcium, and it can cause kidney stones and stuff. So you have to be careful with that. And phosphate's found in soda. So that's why little kids should not be drinking soda, because they need all the calcium they can get for their bones and stuff. All right. Okay. So yeah, you do not distribute it on out. All right. Now, let me do another one. Let's go MN. Let me write it out first. Manganese 4, and then we're going to go permanganate, because this kind of goes along with what you were asking, okay? So manganese is Mn, and it's telling us it's +4. Permanganate, we're going to find it on our pink sheet, and it's right here in the P's. It is MnO4 with a -1. I don't even know if this is a real compound that would form, to tell you the truth, okay? So I might be making this one up. But if we look at this, we got 4 here and 1 here. Which do I need more of? The second one, the permanganate, right? Okay. And how many of these do I need then? I need 4. So we would go Mn parentheses MnO4 parentheses 4. You do not combine this Mn. If there are different components with the same element in it, we do not combine them in the final formula. Because again, that MnO4 is its own thing. All right, we're going to do one more example, and then I'm going to set you free to work on your stuff. All right. Okay. All right, the last example we're going to do is iron. Oh, I'm too high. Iron, Roman numeral 3, and then hydroxide. Stop it. Okay. So iron, what's the symbol for iron? Fe. And it's going to be +3 this time. Hydroxide is one of those exception ones I told you about, right? It is OH with a -1. Which do I need more of? Do I need more OHs? How many OHs total do I need? What's the least common multiple? 3. 3 divided by 3 is 1, so Fe. 3 divided by 1 is 3. So we have to put the OH in parentheses and the 3 on the outside. If we just, this is the most common mistake even on the test that people make, and we do a lot of these. If you only put the 3 there, it only goes with the H. That's why we have to have the parentheses and the 3 on the outside, okay? Be very, very careful with that. Any questions on doing these puppies? Okay, I'm gonna stop the video and pass out the assignment.